Hey everyone! Welcome back to DG Tutorials. Today, I'm unlocking the secrets of rational functions and rational equations. If you're a grade 12 math student, this video is just for you. Ready? Let's dive right in. First up, rational functions. A rational function is basically a function that can be expressed as the ratio of two polynomials. Think of it like this. If you have two polynomials, px and qx, you can write a rational function as fx equals sign px qx, where qx isn't 0. For example, fx equals sign 2x squared plus 3, x, 1, is a rational function. Now let's talk about the key characteristics of rational functions. There are a few things you need to know. First, the domain. The domain of a rational function is all real numbers except where the denominator qx equals 0. Next, asymptotes. Rational functions can have vertical asymptotes, where the function shoots up to infinity, and horizontal asymptotes, which show the behavior of the function as x approaches infinity. Lastly, graphing. The graph of a rational function can show various behaviors including intercepts, asymptotes, and even holes, depending on the factors of the numerator and denominator. Alright, let's switch gears and talk about rational equations. A rational equation involves one or more rational functions. It's an equation that can be written in the form px, qx, equals sign rx, sx, where px, qx, rx, and sx are polynomials and qx and sx aren't 0. For example, 2x plus 1, x, 2, equals sign 3 is a rational equation. Now, how do you solve these? First, you need to find a common denominator, then eliminate the denominators by multiplying both sides of the equation by that common denominator. Finally, solve the resulting polynomial equation. But a word of caution, always check for extraneous solutions. These are solutions that don't satisfy the original equation because of the restrictions from the denominators. Rational equations can also be super useful in real-world applications, like modeling rates, proportions, and mixtures. So knowing how to solve them can come in handy. Now let's recap the key differences between rational functions and rational equations. First, definition. A rational function is a type of function, while a rational equation is an equation involving rational functions. Second, purpose. Rational functions describe relationships between variables, whereas rational equations are used to find specific values of variables that satisfy the equation. And finally, graph versus solve. We graph rational functions to understand their behavior, while we solve rational equations to find the values of x that make the equation true. So in summary, while both rational functions and rational equations involve ratios of polynomials, they serve different purposes in mathematics. Rational functions describe relationships, while rational equations are used to find solutions. I hope this cleared up the differences for you. Don't forget to hit the like button if you found this helpful, and subscribe for more math tips and tricks. See you next time.